discuss about a case study in digital electronics. So what case study we are going to discuss means a digital car parking system. Okay, so we studied digital electronics, but we are not using it in any real-time applications. So now we are going to apply this digital concept in application, real-time application. So what is the application we taken here means smart car parking system. Okay, so how digital electronics is going to use in this system. So let's discuss. So in digital we have two type of circuits. Anybody have an idea what are the types of circuits? Good. Combinational and sequential circuit. So combinational circuit example is encoder, decoder, like multiplexer and demultiplexer. And then sequential circuit example counters, shift register, flip-flops, like this all comes under sequential circuits. We are using these circuits in smart parking system. Okay, so let's discuss how this digital circuit is going to help in smart car parking system. So let's discuss. Yes, proceed.
Okay, I am Ashashri J from second year.
Now,
I am Ashashri J from second year. Let me start with the introduction. So our project is a digital car parking system which counts the number of cars entering or exiting a given parking space. So the main objective was to show the available slots in the car parking space using counters and sensors without using manual effort and time. So counters usually count the number and sensors detect the motion. So thank you.
okay. Next one. We introduced about what are the components we used. Okay, so now Varshashree told about in what is the problem statement we taken, how we are going to analyze it. Okay, next.
I am Shalini. Now the problem statement is manual parking system causes errors, conjunctions and confusions. So to overcome these challenges, we designed a digital car parking management system that can be automatically detects exit and entry of the vehicles and also detect the space count of the cars and vehicles.
I am Selvadarshini from second CSEC. The components that are used in the digital car parking system are first main component is up-down counter IC, which automatically count the number of cars in the slot, and IR sensors, which sends the number of cars that are placed in the counters, and logical gates like AND gate, OR gate and NAND gate, etc., which automatically provide the car services, and power supply, which is used to operate the system, and then resistors and wire which used to connect the OR components, and 7-segment ICs which shows the resistance of the car slots.
Good.
I am Sapariyashree from second year. Here to continue the topic on a case study, digital car parking system. Let me proceed my working principle. So here, when the car enters, the entry sensor sends the signal to the up counter where the count increases. The same way, when the car exits, the exit sensor just triggers the down counter where the count decreases. For example, the 7-segment displays shows the number of available slots, and therefore another example was when the LED lights shows up when there is no spaces left.
I am Sridashni from second year CSE. I am going to conclude the case study that we have discussed. The system accurately tracks the vehicles and display free paces. It is automatic, reliable and free to use, and this shows how digital electronics help us with this case study. For example, in this project we use counters, sensors and different kinds of designs. So this case study is about in which more digital electronics involved.
So thank you students, you done a great job. Okay, so now let's conclude this case study. Smart car parking system using digital electronics. I hope you understand what is the role of digital systems in car parking system. So what are the components we used? What are the components? Logic gates. After that, counters. So logic gates and basic element of the digital system, and counters comes under synchronous sequential circuits. After that, sensors and logical modules are used here. Okay. So thank you all. Have a great day. Thank you.
Thank you.